Hello everyone, myself Vijay Lakshmi Sugnali and this is my YouTube channel WinMaths. Here this YouTube channel helps to those who have studied second PUC NCERT syllabus. I solve the examples, problems and exercise problems with related theory and the syllabus. Okay, here this video contains basically reduced syllabus of Karnataka PU Board 2025 and also some basic results of particular syllabus for Karnataka CET examination. Here in this session we have to discuss the application of determinant and matrices. Okay, based on this concept there is a 5 marks questions will be asked for in your midterm exam as well as in your annual exam. Okay, there is a 5 marks question will be there. Okay, there is a 5 marks question will be asked for your annual exam. Okay, here the first concept is, okay, we discuss the concept now. First one is the concept consistent system and inconsistent system. Okay, here we shall discuss application of determinants and matrices for solving the system of linear equation in 2 or 3 variables. Here we have to consider system of equation of linear equation. Linear means the x is an variable having the power 1. Okay, in the equation the system of equation having the power 1. Okay, here I am considering one equation, that is ax plus by plus cz equals to 0. This is, or I have considered this type of equation because the variable x, y, z having the power is 1. Okay, this type of the equation is called as the linear equation. Here there are 3 variables x, y and z. Okay, in that mainly here there is a 2 conditions are there. One is consistency and another one is consistent system and inconsistent system. Consistent system or inconsistent system. Here consistent and inconsistent means a system of equation is said to be consistent if its solution is one or more exist. Okay, here the solution is one or more exist. For example, in consistent system the variables, there are, I have considered here 3 variables. Okay, consistency means the system of equation has one solution or more solution. One solution or more solution. It means x is having a x is 1 or x have the more than 1 values. Same for y as well as z. Here there are 3 variables x, y, z. Here x, y, z are having a more than one result, that is called as more solution. It has a unique solution, means it has only one value, then it is called as a consistency system. Inconsistency means there is no solution exist. Okay, here there is no solution. There is no solution. Consistency means we have the solution, it may be one or more. Here inconsistent system means there is no solution exist. Okay, here there is no solution exist. Now, solution of system of linear equation using the inverse of matrix. Here in that application for our syllabus we have only the unique solutions. Okay, it means in this chapter we restrict ourselves to the system of linear equation having unique solutions only. Unique solution means the system of equation having only one solution. Based on that concept we have studied the application. Okay, it means unique solution and we discuss only one solution. Okay, the system of equation is consistent system. In that consistent system we have studied only one solution or for unique solution. Here we discuss the concept now. Solution of system of linear equation. Solution of system of linear equation using matrix, using inverse of matrix method. Inverse of matrix method. Inverse of matrix method. Okay, we have to find the solution of the linear equation using the inverse of the matrix method. Okay, we already know the formula of inverse. Here A be a matrix, then A inverse is equals to 1 divided by determinant of A into adjoint of A. Okay, this is the inverse of the matrix A. Okay, here by using this formula we have to find the solution of system of linear equation. Okay, now first the theory part. Here we have considered the system of equation. Okay, here we have considered the system of equation, that is generally a1x plus b1y plus c1z equals to d1, a2x plus b2y plus c3z equals to d2, a3x plus b3y plus c, here a2 b2 c2, here c3z equals to d3. These are the consider the system of equation. Okay, consider the system of equation a1x plus b1y plus c1z equals to d1, a2x plus b2y plus c2z equals to d2, a3x plus b3y plus c3z equals to d3. Then the system of equation can be written in a matrix form, that is a matrix A containing the elements. Here x, y, z are the variables. Okay, I have taken only the elements, that is a1 b1 c1, a2 b2 c2, a3 b3 c3. Okay, this is the matrix A, and here there is another one matrix consider as a x containing the variables. What are the variables? X, y, z. Okay, again we have multiply a, that is a into x. Again we get the system of equation. Here I am consider the system of equation, that is by row by column. We get same result, a1x plus b1y plus c1z. Similarly a2x b2y c2z, a3x b3y c3z. Okay, it is B. Then B matrix containing the elements, that is the variables. Okay, d1 d2 d3. The system of linear, first step is the system of linear equation B can be written in the matrix form, that is ax plus ax is equals to B. Okay, next this is the system of equation. Again the system of equation, the system of equation can be written in the form ax equals to B. Okay, Now we have two cases. Okay, now the what is the steps for solving the 5 marks question? Okay, here first case, if what are the condition for solving the system of linear equation? The first condition, if a is non-singular, if a is non-singular. Okay, the first condition is if a is non-singular matrix. Okay, if a is non-singular matrix, then inverse exist. Then inverse exist. Otherwise inverse does not exist. If a is a non-singular matrix, then inverse exists. That is ax is equals to b, then multiply a inverse on each. Ax is equals to a inverse into b. Again a inverse into ax is equals to a inverse into b. What do you mean by a inverse into a? That is identity into x. A inverse of b, identity matrix with x, that is x only. A inverse into b. Therefore this is the solution of the given system of linear equation. This is the solution of the given system of linear equation. Okay, now we have to solve the problem. When we solve the problem, it will clear for us. Okay, next case 2. Okay, here first case is if a is non-singular. If I check another condition, if a is singular means, okay, here I am checking the second condition, that is if A is singular matrix, then inverse exists. If A is non-singular, if A is singular, when we say A is singular or non-singular, A is singular means determinant of A not equals to 0. Okay, A is singular, it means determinant of A is equals to 0, then inverse not exist. Okay, here inverse not exist. Okay, inverse not exist. Then in this case we have to calculate the, it may be, we have to calculate the adjoint of A into B. Okay, otherwise it is not necessary. Okay, if A is non-singular matrix, then we have inverse exist. If A is non-singular, if A is singular, determinant of A is equals to 0, then it has many solutions. Okay, then it has many solutions. Therefore it has many solutions. Okay, now next we solve the system of equation. Now here working rule for solving the, here working rule for solving system of linear equation. Okay, working rule for solving the system of equation. First one rule is write the linear equation into matrix form. Okay, write the linear equation into matrix form. First condition, write the linear equation into matrix form, that is Ax is equals to b. Okay, first have to the write the linear equation into matrix form. In that second step, check determinant of A. Okay, check determinant value of the of given matrix A. Okay, check determinant value of given matrix A. First one, determinant of A is not equals to 0, then inverse exist. Inverse exist. Okay, determinant of A is not equals to 0, then inverse exist. It means A is non-singular. Okay, otherwise, okay, here check first one step is linear equation into matrix form. Check the determinant value. Then third step, write adjoint matrix. Write adjoint matrix of A. Next step, write adjoint matrix of A. In fourth step, find A inverse using formula. A inverse is equals to 1 by determinant of A into adjoint of A. Okay. In fifth step, take x is equals to A inverse of B. Already we solved this result in the theory part, that is x is equals to A inverse of B. Okay, now substitute A inverse. Already we have calculated in step 4, so we have to substitute. Then x is equals to 1 by determinant of A into here A matrix A1 B1, the A inverse matrix, that is A1 A2 A3 B1 B2 B3, again C1 C2 C3. This is the adjoint matrix. Then B matrix contain the values D1 D2 D3. X is equals to again 1 divided by determinant of A. Find the determinant or product of A inverse into B. Okay, product of the matrix. When we take the product, we get the matrix of. Okay, then again multiply the values. Here we get x, y and z. Okay, then the values of x, y, z when multiplying the A inverse into B matrix. Up to this much, this is the working rule. Okay, again once we have to check the working rule. First step, write the linear equation into matrix form. When they given a system of linear equation, first step we have to write the Ax is equals to B form. After that we have to find the determinant value. If determinant is not equals to 0, then there is an inverse exist. It means A is singular. Okay, if determinant is equals to 0, then there is no solution. Don't do all these steps. Okay, if determinant of A not equals to 0, that time you have to check these steps, otherwise and there is no solution. Okay, next in third step, write the adjoint matrix of A. After that, find the A inverse using the formula. Okay, after that we have to substitute x is equals to A inverse into B. Then we get the 1 divided by determinant. Here there is a adjoint matrix of A and B matrix containing the values d1, d2, d3. When we take multiplication, after that we have get the result x, y, z. Again we have to multiply the determinant value to the whole matrix. We get final x, y, z values. Okay, up to this much the x, y and z values we have calculated. This is the working group. Okay, here for this question there is a 5 marks. Okay, there is a one definite question for 5 marks. Now we have to solve the problem. Okay, now we have to solve the problem. There is a example number 27. The system of equation having two variables. Here x and y are variables. Now we have to solve the system of equation and find the x and y value. Here there is a first step. 2x plus 5y is equals to 1. 3x plus 2y is equals to 7. Here they given system of linear equation. The first step is have to write the system of linear equation into matrix form. That is Ax is equals to B. Okay. First A matrix containing the values 2, 5, 3, 2 and X matrix having the variables x, y is equals to B matrix containing 1 and 7. Okay, first step is completed. The system of equation can be written in the form of Ax plus B. Then we have write one word, that is the system of equation can be written in the form Ax plus Ax into B. The system of equation of the form Ax is equals to B, that is 2, 5, 3, 2 xy. Then we solve Ax is equals to B by multiplying A inverse. Okay, that is A inverse into A, x is equals to A inverse into B. Because I am multiplying A inverse on both sides, A inverse into A, that is identity matrix x is equals to A inverse into B. Identity matrix into x, again x matrix A inverse into B. We want A inverse B. Again we know the adjoint of A. That is, first we have to check the determinant of A. What is the value of the determinant of A? 2 into 2, 4, 3 into 5, 15. 4 minus 15, that is minus 11. Minus 11 is not equals to 0. Okay, the minus 11 is not equals to 0. Therefore, A is non-singular. A is non-singular matrix. Okay, A is non-singular matrix. Then A inverse is exist. That is x is equals to A inverse into B. Up to this much I have to write. This is first step, I have to write in a matrix form. After that we have to, in second step we have to check the determinant value. We have the determinant value minus 11, which is not equals to 0. Therefore A is non-singular matrix, A inverse is exist. That is x is equals to A inverse into B. Up to this much the second step completed. Now third step, have to find the adjoint of A. Okay, we know the adjoint of A in 2 cross 2 matrix by interchanging the by interchanging the diagonal elements. Okay, interchanging the diagonal elements, both are values 2. Okay, then change the sign of the non-diagonal. What do you mean by the plus 3? It becomes minus 3 minus 5. This is the adjoint of A. This is adjoint of A. Then we know that A inverse is 1 divided by determinant value, that is minus 11 into what is the adjoint of A, that is 2 minus 5 minus 3. This is the A inverse. We have to take equation number 1, then substitute A inverse in that equation. Then x is equals to A inverse into B. A inverse is taking minus 1 divided by 11 into A inverse, that is 2 minus 5 minus 3. B matrix containing the values, that is 1 7. Taking the multiplication, okay, here taking the multiplication we get minus 1 by 11, 2 into 1 2, minus 5 into 7 35, minus 1 into 3 minus 3, 2 sevens are 14. Okay, here minus 1 by 11, 35 minus 2, that is minus 33, 14 minus 3, that is 11. Okay, multiplying 11 on this matrix we get here minus into minus plus 33 by 11 3, minus into plus minus 11 into 11 11 ones are, that is 11. Here x containing the values 3 minus 1. Therefore x is equals to 3 and y is equals to minus. The system of equation having the values x is equals to 3 and y is equals to minus 1. This is the method for solving the system of equation. Once we have to check stepwise, that is they given the system of equation, that is 2x plus 5y equals to 1, 3x plus 2y equals to 7. First step, have to write the system of equation can be written in the form Ax equals to b. After that A matrix and x b. Okay, A matrix taken from the values 2 5 3 2. Okay, then x y are the variables, then the values are the B matrix. Then check the determinant value, that is determinant value by calculating the determinant minus 11, which is not equals to 0. Then therefore A is non-singular matrix, then they in an A inverse exist. Okay, what is the A inverse? We already solved, that is x is equals to A inverse into B. This is equation number 1. Again we have to find the A inverse. Okay, well, how to find the A inverse? By using the formula A inverse is equals to 1 divided by determinant of A into adjoint of A. For that one, we have to find the adjoint first. After that, we have to substitute determinant value and adjoint of given matrix in the A inverse. We get A inverse. Again, substitute A inverse in equation number 1, that is minus 1 by 11 into adjoint matrix into B. I have to multiply. We get the variables x, y. Therefore x is equals to 3. Again multiply each term by 11. Here minus 33 divided by 11. 11 ones are 11 threes. Here 11 by 11, that is 11 ones are 11 ones are, we get minus 1. Therefore x is equals to 3 and y is equals to minus 1. Here example number 28, solve the system of equation by using the matrix method. This is the one of the important 5 marks question in midterm as well as annual exam. Here they given 3 variables x, y, z. Okay, here we have to solve the system of equation by using the matrix method. First step, the system of equation can be written. The system of equation can be written in the form AX. The system of equation can be written in the form of AXB. A matrix containing the elements 3 minus 2 3. Here 2 1 minus 1 4 minus 3 2. And X matrix containing the variables X, Y, Z. Then B matrix containing the elements 8 1 4. This is the system of equation. Okay, the first step is completed. The system of equation can be written in the form of Ax is equals to B. Then second step, we have to find the determinant of A. Okay, finding the determinant of A, I am taking row, first row, using first row, therefore neglecting the first column, first row, that is 3 into 1 into 2 2 minus 1 into minus 1 minus 3. There is a 1 minus, that is minus 3. Here minus is, and again minus 2, that is neglecting the row, column 2 2 into 2 4. Okay, next 4 into minus 1 minus 4. There is a 1 minus, that is plus 4, plus again 3 2 into minus 3, that is 2 into minus 3 minus 6. 4 into 1 minus 4. Okay, now 3 into 2 minus 3, that is minus 1. Here minus into minus plus 2. 4 plus 4 8 plus 3 minus 6 minus 4, it becomes minus 10. Okay, next 3 into minus 1 minus 3. 8 into 2 16. 3 into minus 10, that is minus 30. Here minus 30 minus 30 minus 33. Minus 33 plus 16. Here it is minus 13 plus 16, have to minus. 13 minus 6, it becomes 7. There is a minus 3 plus 2, that is minus. Then the determinant value is minus 17, which is not equals to 0. Therefore, A is non-singular. A is non-singular. The second step is completed. Now calculate adjoint. Okay, here A is non-singular. Then there exists A inverse. Then there exists A inverse. Okay, here now we have to calculate the A inverse. For that inverse, we have formula A inverse is equals to 1 by determinant of A into adjoint of A. We want adjoint matrix, that's why I am calculating direct adjoint, that is A11. Consider row wise A12, A13. Okay, here I am taking matrix neglecting the first row, first column, that is 1 2. Neglecting the column 1 minus 1 minus 3 2. Here for the second element neglecting 2 minus 1 4 2. Okay, again for the third one, 2 1 4 minus 3. Okay, these are the first row. Again we want second row, A21, A22 and A23. Write the elements here. For A22, neglect second row, first column, that is minus 2 3 minus 3 2. For this one, 3 3 4 2, 3 3 4 2. Again for the third element in second row, third column, 3 minus 2 4 minus 3. Next, considering third row, A31, A32, A33. Okay, the elements are minus 2 3 1 minus 1. Again for the second one element, neglecting the row column, 3 3 2 minus 1. For the last element, 3 2 4 minus. Okay, for the last element, 3 2 2 plus 1. Okay, once we have to check before calculate, we have to check the entries. Okay, here for the first one, the first element, neglecting this row column, what are the elements? 1 minus 1 3 2. Here I am writing 1 minus 1 3 2, it is correct. For the second one, have to check the values. What are those? 2 minus 1 4 2. Here I am writing 2 minus 1 4 2. For the third element, have to eliminate 2 1 4 minus 3. Here I am writing 2 1 minus 3. Similarly, for each element, check the eliminating the rows and columns. Okay, now we have to calculate the values. That is 1 into 2, that is 2, minus into minus, it is plus, then there is a 1 minus, 3 into minus 1, that is minus 3. Okay, next 3 minus 3, it becomes minus 1. 2 into 2 4, 4 into minus 1 minus 1, there is a 1 plus, that is 4 plus 4 8. Again 2 into minus 3 minus 6, 4 into 1 minus 4, it becomes minus 10. Again minus 2 into 2, that is minus 4, 3 into 3 minus 9, there is a 1 minus, that is plus 9, 9 minus 4 5. Then 3 into 2, it is 6, 4 into 3 minus 12, then 6 minus 12 minus 6. Again is equals to 3 into minus 3 minus 9, 4 into minus 2 minus 8, there is a 1 plus, okay, minus 1. Again minus 2 into 1, that is plus 2, 1 into 3 minus 3, it becomes minus 1. 3 into minus 1, that is minus 3. 2 into minus 3 minus 6 minus 9. Here 3 into 1 3, 2 into 2 4, because 2 into 2 minus 2, there is a 1 minus, it becomes plus 7. Okay, these are the values. Okay, direct, these are the values we have calculated. After that, we have to check the, or we have to make the place values, because now we have to calculate only minors, but we want adjoint, That's why I am writing directly adjoint by multiplying this by first one is plus, here minus, plus minus plus minus plus minus plus. Okay, now we have to multiply symbols. Okay, we have to multiply the symbols starting with plus minus plus minus plus minus plus minus plus. Okay, then minus plus into minus, minus 1, here minus 8, plus into minus, minus 10, minus into 5, minus 5, then plus into minus, minus 6, minus into minus, plus 1, plus into minus, minus 1, minus into minus, plus 9, plus into 7, plus 7. Okay, now we want adjoint by taking or grouping the 3 values. Here I am taking row wise, but here I am grouping column wise. Okay, then directly I am writing adjoint of A is equals to minus 1 minus 8 minus 10. In second one is taken minus 5 minus 6 1, then minus 1 9 7. This is our adjoint A. Then A inverse is 1 divided by, what is the value, minus 17 into adjoint minus 1 minus 5 minus 1 minus 8 minus 6 plus 9 minus 10 1 7. Okay, now we have to calculate the A inverse. Okay, then already we calculate A inverse. Again we want x values. X is equals to A inverse into B. Substitute values in this matrix. X is equals to 1 divided by minus 7 into determinant of minus 1 minus 5 minus 1 minus 8 minus 6 9 minus 10 1 7 into B matrix, that is 8 1 4. Multiply now. Here we want to calculate now. Minus 1 in taking multiplication row by column, minus 1 into 8 minus 8 minus 5 into 1 minus 5 minus 1 into 4 minus 4 minus 8 into 8 minus 64 minus 6 into 1 minus 6 minus into 9 into 4, here plus 9 9 into 4 36, then minus 10 into 8 minus 80, 1 into 1 1, 7 4 28. Okay, we have this much. X is equals to, sorry, here minus 1 by 17 is there. Okay, here also minus 1 by 17, then x is equals to minus 1 by 17 minus here all are minus 8, directly we add it. 8 plus 5 12, sorry, 8 plus 5 13, 13 plus 4 17, here minus minus 64 minus 6 minus 70 plus 36 minus 34 minus 80 plus 29, it becomes minus 51. Now multiply minus on each, we get 1 by 17 into, we get 1 by 17 into 17 34 51. Okay, directly multiply each by 17, we get x matrix is equals to 1 2 17 1s are 17, 72s are 34, 73s are 51. Therefore x having the variable values, x is equals to 1, y is equals to 2 and z is equals to 3. The system of equation having the solution x is equals to 1, y equals to 2 and z equals to 3. Okay, Up to this much, the solution is completed. Here I am solving 2 cross 2 matrix and 3 cross 3 matrix. Here 3 cross 3 matrix will be very important for examination. This example is very important because this example will be asked more times in the examination. Okay, thank you for watching my videos. If you have any doubt, write your doubt in comment box. Thank you. Please subscribe my channel and send to your friends. It may helps to them. Thank you.